other applications for when they need it. So we like this idea of resource pooling, not having those islands, which leads to this idea of rapid elasticity. My allocation of resource for any particular app or tier of an app, I don't have to scale all the different tiers. Maybe it's a web front end, maybe there's a business logic, maybe there's a database. They can all scale individually as needed rapidly. As the load increases, I can scale to meet it. As the load decreases, I can scale down and stop wasting resource and free it up for someone else. So by doing that pooling, I have lots of resource available, and that cloud's going to give me these scale capabilities. And a measured service. Maybe I do want to do show back, which is, hey, business unit A, this is how much resource you're using. Or maybe even that show back, I might do charge back. I bill them for the amount of resource they're using. And those are defined in a very specific document. Now, if I think of types of service, it's all about responsibility. That's what it really boils down. Now, if I think of scale to meet it, as the load decreases, I can scale down and stop wasting resource and free it up for someone else. So by doing that pooling, I have lots of resource available, and that cloud's going to give me these scale capabilities. And a measured service. Maybe I do want to do show back, which is, hey, business unit A, this is how much resource you're using. Or maybe even that show back, I might do charge back. I bill them for the amount of resource they're using. And those are defined in a very specific document. Now, if I think of types of service, it's all about responsibility. That's what it really boils down to. I, as a company, unless I'm in an IT business, and even then, for the most part, I don't care about the IT. I don't care about a physical box. I don't care about operating system. I don't care about a runtime. I care about my application that is bringing business value to my company, that helps my company make money, that differentiates my company from another company. All I care is about the business value. Everything else is cost of business. I have to do it. I don't really want to be doing it. So as we talk about types of service, it's about shifting who is responsible. And ideally, most companies want to be as responsible for as little as possible that's not generating revenue. So I like pizza. And I can think about, well, pizza, initially, I could make it at home. Now, if I make my pizza at home, I'm responsible for getting the pizza dough and the sauce and the cheese and the toppings. I have to have power, fire, an oven. I need electricity or gas. I want some drinks. I need a table, somewhere to eat it at. I need cutlery. I need plates. I need everything. I have complete control of all of these elements, the exact contents of the dough, the exact type of cheese, the exact ingredients in my sauce, the exact type of oven. But I have all the responsibility. I have to think about all of those. Things. If I start shifting to a take and bake, I go somewhere and they've pre-made the pizza. All I have to do is take the pizza, so I'm not focused anymore about the pizza dough or the cheese. It's provided for me. All I focus on is taking that pizza, but I have to provide my own power, my own fire, my own oven, my own table and cutlery and drinks. I can get pizza delivery. So now I'm shifting even more of the responsibility. I don't have to think about cooking it anymore. The power, the electricity, the oven. But I still need drinks. I still need a place to eat it. Probably not cutlery. Where that came from. Just use our hands. I just need to provide. So I'm responsible for less and less, but it also means I have less control about these things. Maybe I don't care. And that's probably the case. When a pizza gets delivered to me, do I care about the oven they used? Do I care about where they got their electricity from? No. As long as it tastes good, that's all I care about. Or it could be a complete dining out. I'm not responsible for anything other than consuming and eating my yummy pizza. And I like pizza. Pizza will come up quite a lot. So we can apply this same idea to computers, thankfully. If I think about a stack, there's networking, there's storage, there's the physical compute servers. There's typically a hypervisor, Hyper-V, VMware. There's an operating system, Windows, Linux. Middleware systems, those abstractions, maybe it's MQ or some kind of bus technology, a runtime to run my application like .NET or Java Enterprise Edition, J2E. And then I get to my application and my data. This is what I care about. This is what provides the business value. But on premises, my organization is responsible for everything, different teams most likely, but I also have all the control. I can pick every aspect of this. As we start moving to cloud services, even if it's private, what I want to offer people, we start off with infrastructure as a service. And what this can be thought of is as a virtual machine at a very basic level. So here the vendor, this is Microsoft if it's Azure. This could be your IT team on premises if it's a private cloud. They're responsible for the hypervisor, for the physical fabric, the compute, the storage, the networking. The consumer of infrastructure as a service gets a virtual machine. They're responsible for everything inside that virtual machine. The operating system, installing middleware, installing runtimes, maintaining them, which means patching, firewall, policy, backup, disaster recovery. The list goes on and on. So I have all of the flexibility still within that VM, but I have all the responsibility. I have to think about all those different elements. Now, when we talk about Azure and we talk about a VM, there are extensions, there are services that help me do all of those things I just said. Backup, DR, policy, firewall, anti-malware, you name it, there are things that help me. But I'm still responsible for thinking about that tooling. And then we get to the bits we really care about. Then we have platform as a service. So now the vendor is even taking care of the operating system, the middleware, the runtime. They're taking care of the patching of the backup. If they do backup, they may not need to. They just provide a place for me to deploy my custom app with my data. My focus on my line of business application is just my app. I don't care about all of those other things. And when we talk about PaaS, this also could be a database as a service. I just think about my schema, my configuration, the data I put inside it. Could be desktop as a service. It's a place where I'm publishing applications or entire desktops. And then there's software as a service. Now this isn't Azure. This will be more something like Microsoft 365, Office 365, Dynamics 365. It provides the business application, the end service I need. Whereas PaaS is not really providing the business application. It's providing that foundation I can build my business application on, but it's not doing the business logic. Whereas a SaaS is actually doing that business logic, is providing that capability for me. Minecraft is a good example of this. I could run my own Minecraft server, and I could do it by running it inside a VM. I would have to install the OS, I'd have to install the Java runtime, I'd have to install the Minecraft app, but I can add a lot of configuration and flexibility in that. Or Minecraft offers Realms, where it's just a complete hosted solution, and I just think about, well, maybe I want to do an extra backup of my world, but I'm not thinking about any kind of OS or Java runtime. I'm not thinking about the Minecraft executable and updating any of that. So I get different levels of responsibility. I have to do less and less as I move up here, but I might get a bit less configuration, a bit less flexibility, where I can't add maybe certain types of add-ins when I use more of the PaaS and the SaaS. For most companies, I want to get as far to here if I can. If there's a SaaS solution that does what I need, fantastic. I'm going to go with that. If it's a custom line of business application, how far on the PaaS scale can I get? Now, there's different types of PaaS. I can think of serverless, where I just pay for the work something does, and it's triggered by something happening. An item arrives on a queue, a file is placed somewhere, a timer, an API call comes in. Maybe it's a container environment, a Kubernetes. Maybe it's hosting a web service, app service. Or maybe it is more of those auto-scalable virtual machine-based resources. The important point though, when we think about the cloud, I remember when I originally spoke to customers, they were like, well, how long will it take once I provision a VM to have it available for you to rack the server? There's no racking of servers that will impact your service. Obviously, behind the scene, there are servers. There are servers in racks, in clusters, in data centers. But this is massive scale. These are all available. There's lots of idle capacity waiting for customers to provision. So when I create something, there's no delay other than a couple of minutes for most things. It just has to go through and maybe copy your VM image to the new storage and go through some specialization routine, and it's up and running. So if ever you hear, well, it's going to take us a couple of weeks, that's not a public cloud. There's something else going on with that. Now, when should I use them? And there is no right or wrong answer to this. Every company has different priorities. Every company has different goals. Every company has different top-level objectives of what they want to be. But it's all about shifting responsibility. It's all about being able to consume more advanced types of service and enabling the business to really focus on what matters. If I think about most companies today, they're going through a number of transformations. Digital transformation is huge. It's the idea of shifting, how do we do business? How do we actually perform our transactions? And it's moving from those old style ways to IT based. It's moving to online business. It's moving to technology solutions for my business activities, for my transactions, for my operations. When I move to the cloud, it lights up a lot of those scenarios. Maybe I just want to modernize my business. And once again, if we think about, well, on premises, maybe I had VMs, okay? I want to modernize, I want to go to containers or PaaS services or database services. They're just all readily available when I think of the public cloud. So moving to the cloud can be a catalyst to modernize my architecture. Maybe I just want to enrich my environment. Now, different organizations, they have different priorities. They can operate services, they can operate data centers at different price points. It will always come up. Oh no, I can run my data center cheaper. That's really pretty unlikely. I've seen a lot of reports on this. The electricity bill alone for most companies would be more than, hey, I can run those services in Azure. There's a certain amount of efficiency. We think about data centers, the power coming in, how much of that is used to actually provide service as opposed to wasted through other cooling and environmental factors. And if you look at things like Azure, it's just an interesting thing to look at. Azure's really been working on this PUE, and it's all about this power usage effectiveness. And the Azure data centers are just some of the lowest in the world. So it's all about this idea, total energy needed for the facility, how much is actually used for the computing. And Azure is getting really close to almost 1. i.e. it's super, super efficient. But they also talk about, well, water usage effectiveness and how efficient and how much they could not waste in those various environments. And so maybe you believe you can run it cheaper. It's probably not the truth if you really factor in everything. The physical building, the power, the networking, the people, the security, the tax on the building, the buying the physical racks. If you think of everything, it's actually pretty unlikely. But What other factors do you have as an organization? Maybe I'm trying to minimize my environmental impact and move into these public clouds. They have better efficiency than me. But I just don't want to be in that business in the first place. I want to focus on how can I just provide my business value. I always think about the old factories. The old factories used to generate their own power. But then the utility companies came along who could operate cheaper and have better quality of power. So the factories stopped having their own generators and they used the grid. For a large part, the technology for computing is going that same way. Requirements for resiliency, DR, business continuity, high availability. I might have a great data center. Well, where's my DR? That means I have to have a second data center or maybe a third data center. That gets really expensive for saying I hope I never ever have to use. Proximity. I have customers in Europe, multiple parts of Europe, east and west coast of the US, all over the world. Do I want to operate data centers at all of those locations? Or I can use a public cloud service who have regions in all of those different geographically distributed areas, and I can just stand up a couple of VMs or an app service in each of those. They provide this geographical routing, they provide the failover. Hey, it's a lot better for me and my customer experience that now there's instances of my service all throughout the world. I just couldn't practically do that on premises. So that could be a very, very big reason for wanting to actually do this. I only pay for what I use. So think about the DR scenario for a second. If it's not running, I'm not paying for it. Now, there might be certain licenses. It depends on the type of DR we're doing. Maybe there's some storage I'm paying for. I'm probably not paying for the compute side. So I'm paying a lot less money. I pay for the amount of storage I'm using, not for the amount I might need over the next 5 years, which I have to do with a SAN. I pay for the number of hours that compute service is running, not 24/7. And again, if I think about auto scale and I change the number of resources based on the load coming in, paying for what I'm using is really, really important. And that's very hard to do with us on premises. We have the physical boxes. So this fact that I pay for what I'm using opens up a lot of key scenarios that are unique to the public cloud. The one I like the most, because it involves pizza. It's Super Bowl. I can't stand American football. I tried to watch it once in my first year in the country, and it was the most boring thing in the world. But don't judge me, personal preference. However, if I'm a pizza restaurant, what I learned was on a typical Friday evening, a pizza restaurant might be 3 times busier than any other night of the week. Which means for maybe 5 hours on a Friday night, or as a pizza restaurant, I have to have 3 times the amount of infrastructure available to take orders. The rest of the time, it's only a third being utilized. What a waste. Super Bowl, people eat a lot of pizza, 3 times more than even a Friday night. So now for a period of what seems like 18 hours, but I think is a 4-hour game, I need 3 times even the infrastructure that I need for a Friday night. Well, that's ridiculous. That would mean for the rest of the year, and most times, it's only using a 1/9 of the overall capacity. That's insane. Think about the public cloud. Well, I could burst up for those 4 hours and then shrink back down again. I'd only pay for whatever the seasonality, that variation in requirement of load, is to meet the requirement. And that idea of only paying for what I need lends itself to a number of scenarios. So the pizza is predictable bursting. I know there's a seasonality, and I know what it is. I know 8 a.m. every day during the week, people come and log on, so there's a certain amount of authentication storm. In the evenings, I'm a pizza restaurant. I'm a tax company, I get a tax month once a year. I'm hosting the Olympic site every 4 years. There's some kind of predictable bursting, so that ability to scale up and down and only pay for the amount I'm scaled, that's a key scenario. I'm starting out. Maybe I'm a new company. Maybe I'm a new project. Maybe I'm a new app. But I'm something new. Maybe I don't even know what my growth is going to be. But the cloud has this infinite amount of resource available. If I'm growing, I'm being successful, I'm generating money, so I can pay for the additional load and the additional resource to support that load. So if I'm growing fast, great, I can do that. And there's an opposite of that. It's also really useful if it then fails. Companies fail. If I have to get some huge initial outlay of capital expenditure to buy a whole bunch of servers, well, that's very stressful on my startup. Huge amount of money I need to buy all this stuff. And then if I fail, it's all been wasted. And spending all that money may encourage me to fail because it's put a real strain on my finances. Whereas the public cloud is operational expenditure. It's not upfront. I pay for it as I operate, as I'm running my company. So there's not a big initial outlay, and I just pay for what I'm using as I grow. So if I do fail, I've not wasted a bunch of money, and I didn't have that huge capital expenditure that stressed my finances from the start. Could be unpredictable bursting. Running a site, some celebrity mentions my site, and I get this huge spike in traffic. Well, I auto scale. This huge spike in interest comes in, I scale up my resources to meet it. And maybe it's even on and off. Again, that Olympic scenario. I'm only on for a few weeks every 4 years. Tax company, I'm only on for a month every 12 months. Whatever that is, I can stop and start it and just pay for what I need. So all of these are because I pay for what I'm using at any particular second in time. So we typically see, I'm trying to build trust in the cloud. I might start my test and dev. Now you have to be careful with test and dev. Test dev has a huge amount of churn. Create, delete, create, delete, create, delete, which means the cloud is fantastic for that. When I think of testing though, make sure your final test environment does match production. I don't want to go and do all my testing in Azure and then run in production on a completely different platform. The final validation test should be on the same platform as production. But definitely because of that high churn, using the public cloud, the ability to spin up the environments very quickly and tear them down, it's super useful for that. Disaster recovery. I only pay for it when I'm using it. I'm not paying for a second data center that's mainly idle. Hey, I'll use the public cloud for that. DMZ. I've got internet-facing properties, and I'm not that comfortable with my security or my processes that I want to host it out of my data centers. So that public-facing stuff, I'll stick in the public cloud. Other things, I'll have an isolated separate network. Maybe I do connect them and I've got a very strict firewall, but that internet facing, I'm going to get off of my infrastructure. Special projects. Comes back to that idea of churn and spinning things up quickly, pay for what I need. I don't want the capital expenditure. I can go and run it up there. A lot of this is about capital expenditure, buying a big asset versus operational expenditure. Hey, I'm paying the thing to run it for any given week or month. But many are just all in. Many companies today realize, yes, the cloud's cheaper, realistically, but also it offers a lot more types of service. It enables me to accelerate. It enables me to do that scaling and operate for what I need as a company. They don't want to be in the data center business. They don't want to operate physical data centers and have the security and all of the people just managing servers. The list of all of the Azure product functions, always. there are limits. Portal, and also there's an API now that lets us and lots of different power and lots of copies. I still have to reboot it. There's still downtime. If the host crashes, paused for 30 seconds. We're super resilient, so let's build in resiliency through software-defined networking, through software-defined storage, through multiple instances that not only make it more resilient, because I've got lots of instances now, but it also enables me to better match the demand by adding and removing them as I need it. So Microsoft can provide leading solutions across. So what does all this mean? Again, does it do this? Does it do this? Does it do this? This is when you're focused on integration, actually solving problems. And that's where they're going to operate in to get to. And so, yes, does it have a certain Azure and AWS. I think even Google Cloud is kind of sliding. Hey everyone, welcome to the identity portion of the masterclass and the V2 version of this. Identity is critical. When we think about the world today using resources, our digital identity, well, that is the security perimeter in modern systems. Most of the applications we access no longer live in the confines of our network. They're on someone else's network. They're out there accessed over the cloud. And so it's the identity that is the key to opening up our access. So identity is more important than ever when we think of any kind of modern computing. And we think of identity, it's not just users, it's devices, it's applications. So we're going to explore all of the different areas of that. So think about what are some of the basics around identity, and then what is Active Directory domain services versus Azure Active Directory. Thinking about authorization, controlling access to applications that trust our Azure Active Directory through things like conditional access. How can I have strong authentication with multi-factor authentication, MFA, and passwordless? How can I get permission just in time? So I want to remove credentials and permissions that I'm not using and only get them when I actually need them. And we'll look at some other things as well. Things about, hey, how Azure AD relates to subscriptions, federation, access reviews, just some all-up understandings of identity. So why do we need identity? Well, for any service, whatever I'm accessing, be it SharePoint or Exchange or Azure or third-party SaaS applications, I have to be able to apply a principle of least privilege. I only have permission to do the things I absolutely have to do at that moment in time to perform my function. And again, when we talk about the service, the principle, this could be a user, it could be a machine, it could be an IoT device, it could be an application. Doesn't matter what it is, I want to be able to uniquely identify the principle that's performing some action. And I don't like shared accounts. With shared accounts, I get no visibility into, well, who actually performed that action. I can't audit, and I can't be granular because if I'm sharing an account, that account has to have the sum of the permissions of all the different actors that may be using it. So I want this least privilege, which means every principle, every actor has to have their own unique identity. And then what I'm going to do is I'm going to give certain actions, and typically we take actions or permissions and we group them together into roles, and I want to assign that to specific security principles, be it a user, a group, a device, an application, at a certain scope. So we don't just think least privilege in terms of what I can do, we think of least privilege in terms of, well, what I can perform those actions against. Now we're going to focus on the security principles when we talk about Azure Active Directory, where those identities actually live. Any actor, remember, should be uniquely identifiable. That's a core tenet of everything we're doing. And if I think about, well, I need identities, I have to have some central storage of where those identities live. And then where those identities live would be responsible for making sure some actor is allowed to use that identity or is that identity through maybe knowing some secret or having some private key associated with a certificate, and then controlling, well, what it can then access. So if I think of those things together, I could think, well, I need an identity provider. So I have the idea of an identity provider, and that identity provider is responsible for storing those credentials. So I'm going to have credentials that has some way to authenticate, I prove I am that credential. Maybe it's got some secret, like a password. We're used to that idea. And then what will happen is various applications will trust that identity provider for its control of access. So here I'm going to trust the identities in this identity provider, and then once that's told me, oh, here's a token for this person, I trust this identity provider to have done a good job. If they've got a token, I know it did the right checking, and then I can control, well, what can it actually do? Some roles within this. So this identity would then have certain roles for this particular application. And then that person or device or application would authenticate, i.e. prove they are allowed to act as that identity by knowing this secret, by having that private key. And then the identity provider will give them a token. So it will give them a token because they've proved they're allowed to use this identity. And then they will give this token to the application that trusts this identity provider. And that's the key idea when we think about this. And I drew one application, but what you're typically going to find is you have many applications trusting the identity provider. So this is the key point. I need this central identity provider that's going to have all the identities that actors, users, devices, apps will be able to authenticate against, to get tokens to then use to authenticate and then be authorized for different sets of permissions against apps that trust that identity provider. So the whole thing here is I have to have this central identity provider. Well, there's actually some movement when we think about this. Because what's happened is, do I really need that an identity provider be responsible for making sure sure some actor is allowed to use that identity, or is that identity, through maybe knowing some secret or having some private key associated with a certificate, and then controlling, well, what it can then access. So if I think of those things together, I could think, well, I need an identity provider. So I have the idea of an identity provider, and that identity provider is responsible for storing those credentials. So I'm going to have credentials that has some way to authenticate, I prove I am that credential. Maybe it's got some secret, like a password. We're used to that idea. And then what will happen is various applications will trust that identity provider for its control of access. So here I'm going to trust the identities in this identity provider, and then once that's told me, oh, here's a token for this person, I trust this identity provider to have done a good job. If they've got a token, I know it did the right checking, and then I can control, well, what can it actually do? Some roles within this. So this identity would then have certain roles for this particular application. And then that person or device or application would authenticate, i.e. prove they are allowed to act as that identity by knowing this secret, by having that private key. And then the identity provider will give them a token. So it will give them a token because they've proved they're allowed to use this identity. And then they will give this token to the application that trusts this identity provider. And that's the key idea when we think about this. And I drew one application, but what you're typically going to find is you have many applications trusting the identity provider. So this is the key point. I need this central identity provider that's going to have all the identities that actors, users, devices, apps will be able to authenticate against, to get tokens to then use to authenticate and then be authorized for different sets of permissions against apps that trust our identity provider. So the whole thing here is I have to have this central identity provider. Well, there's actually some movement when we think about this. Because what's happened is, do I really need an identity provider? There's a whole decentralized identity movement happening right now. It's really gaining a lot of momentum. The idea really is the user becomes the center of that picture. If we go back to that whiteboard, what's in the middle? What's in the middle is the identity provider. It holds holds all the power. It holds the identity. So technically, it could delete that identity. And then I lose access to all my apps and all my data. It could give it to someone else. It could do a poor job and leak my credentials, and then someone else could do things with it. It controls maybe what the other apps can see. So do I have great control of my information about me and my data? Maybe not as good as I would like it to be. And so the idea of decentralized identity is it puts the user in the center of that picture. So the idea becomes the user or the other entity. It doesn't have to be a user. It could be an organization. But the entity owns their own identity. It controls the information shared. And then other entities can issue verifiable credentials to that identity. They would be the subject, that the subject can then choose to present to other entities. They would be verifiers, receiving parties, but they can control, as the owner of that identity, the user can control maybe what identities it wants to share. It can control maybe which parts of that. So maybe it doesn't expose how much I earn, but it can expose, yes, I am employed by this company. It can expose, yes, this person is over 21, but doesn't expose their date of birth. So we can do a lot of things with this. And this is all rooted in some kind of trust system, because when you take away the IDP, because the IDP was the trusted party, if there's no direct relationships, how does that receiving party, the verifier, know, well, this verifiable credential, this attestation from some issuer really came from them? How do I know you are really you? So there's a whole trust system that forms the foundation of this. So if this is all built around an IDP, if I think about decentralized, decentralized identities, the whole point of decentralized identities, in the middle is the actor. So I'll say me. So in a lot of ways, I am my own identity provider. But the whole problem with this is no one trusts what I say about myself. People trust other organizations. They trust government. They trust banks. They trust educational institutions. So if I just tell some verifier, oh yeah, I'm this age, they go, I don't trust you. Same as in the real world. It's not really what I say about myself. It's about what some trusted party, my driving license, says. That's what people trust. And so the point here is we have the same idea of some company, some government institution, but they are the issuer. And all of these different parties, we're going to have something be called a decentralized identifier, a DID. So everyone has this decentralized identifier. So this is not a decentralized identity. There's a difference between what these things mean. It's a decentralized identifier. And what's happening is there's some trust system. Now the actual trust system can vary. Some of them are built on blockchain. Some of them are built on combinations of layers of interplanetary file systems, which is then rooted in a blockchain. Some of them are based on owning a certain domain, and there's different ways to do this. But they're all rooted in some trust system. And now what will happen is this issuer, well, they will create a verifiable credential. So that verifiable credential they create, they will make some claims about the subject. So remember, the subject is me, so I am the subject, and they are the issuer. So they're the issuer of this. Then they give it to me. So they give me this, and I will then store this in my digital wallet. And now when I want to use it, there's some verifier. Maybe it's someone I'm trying to get a job at. Maybe it's, doesn't matter, it's a coffee shop. They're going to challenge me, and they're going to want a verifiable presentation. So I can now pick which of these verifiable credentials that are in my wallet do I want to share with them. So I now have all the choice. I can say, well, I'll present this one. I'll sign it with my credentials that I have, my decentralized identifier. And what they can do is they have a DID as well. So they have a DID, which is rooted in the trust system. And when they get this credential, they can go and consult the trust system to look up this DID, look up my DID, verify they have the right cryptographic materials, and validate, hey, this really did come from this issuer. I really am me. So this idea of decentralized identities, using decentralized identifiers and DID documents, there's a whole set of things around this. I did an hour-and-a-half video all about verifiable credentials, but this puts the actor in the middle, not the identity provider. I have complete control now over my identity. So this is a direction. This is happening. It is gaining a lot of momentum. So over time, you definitely will start to see more and more about this idea of, hey, verifiable credentials. So this is what it is. There is no centralized IDP. I have my wallet, which is just some user agent, some application on a device. It might be backed up to the cloud, but I maintain the control of the identity. And that's the key part. So it's just a little bit of a segue, just to make sure you understand that typically when we do think about a centralized identifier, identity provider, and that is what Azure AD is. But realize this decentralized identity movement is happening, but we're not really going to focus on that anymore. Microsoft Entra does have a solution for those verifiable credentials, both issuing and verifying them, and we'll see bits of Entra as we go through this module. But we are going to focus on this module around a centralized identity provider. So if you want to think about a centralized identity provider, enter Azure Active Directory. Now I will say, I mentioned the word Entra. Microsoft are moving a lot of their identity solutions under this Microsoft Entra umbrella. So Azure Active Directory, if I think about the verifiable credentials, some of the identity governance solutions, more and more things that are identity related are going under Entra. They purchase CloudKnox, and there's an Entra permissions management set of solutions. So if you hear Entra, it's an umbrella for a lot of identity related Microsoft technologies. So this is the idea. But Azure AD is the identity provider for, well, Microsoft clouds, yes. So if I'm using Azure, if I'm using Microsoft 365, so Exchange Online, SharePoint Online, Teams, if I'm using Dynamics 365, it all trusts a specific Azure AD instance that I have for my company. But also third-party SaaS applications, software as a service apps. It could also be applications I write. So many, many things now will leverage these identity providers for the cloud. Now, before I go into, I guess, more detail about this, it's important to understand Azure AD is not Active Directory domain services in the cloud. It is completely different. I think marketing said, oh, people like Active Directory, we'll use that name, but it's not. If I think for a second, if I actually look at Active Directory, so the Active Directory we know and love. So if I think of Active Directory, and its full name is Active Directory Domain Services. So what do we have with Active Directory Domain Services? Well, it speaks protocols like NTLM, it speaks Kerberos. If I want to interact and query it, well, I can use things like LDAP. It uses a huge, vast range of different ports to communicate because it's designed to run on a certain network. So I'm not that worried about ports I might need for this to actually function. It supports organizational units. So I have OUs, so I have a structure. And I can apply a group policy object. I can do delegation at those levels. And that's great for when I'm on premises, when I have that. But if I then start to think about, well, there are those cloud workloads. So I am starting to use some SaaS application. I don't want to have a separate identity. So one of the things I could do is I could set up some kind of federation solution. For example, ADFS, but there were third-party ones. And I could federate. And what federate lets me do is now this application will trust tokens generated from this federation service. It typically will be SAML or WS-Fed if it's more Microsoft focused. It's trusting this for the authentication, and then it would give the user some token that it would use. But there's a fair amount of work for this. I have to maintain this ADFS infrastructure. I have to maintain certificates with the people I have federations with. I have to have internet-facing services. So this, although is a solution, and it definitely avoids me having to have separate credentials on these SaaS apps, there's a lot of work to maintain these federations. So, if I think in this new world of cloud applications and wanting to, hey, use the cloud for things, the solution is therefore Azure AD. So what Azure AD does, if I think of Azure AD, and it is not AD in the cloud. Forget about that. Azure AD is all based around HTTP, HTTPS. So it speaks web protocols. It speaks things like OpenID Connect, for authentication. It speaks OAuth 2 for authorization, for delegation. It speaks SAML. It speaks WS-Fed. So these are all great to use over the internet where maybe I only have port 443 open to me. It's designed to speak cloud, and that's really the key point around all of this. So it's speaking cloud. And then when I think about all these other cloud applications, this could be Azure, this could be Microsoft 365, Dynamics 360.
Of monitoring and evaluating data to gain actionable insights is called data analytics. And it's one of the most important skill sets you can develop for a career in digital marketing or e-commerce. That doesn't mean you need to be a statistics expert to work in these fields. What it does mean is that most entry-level roles you'll encounter involve working with data in some way. Let's go over a few of the main data analytics responsibilities you might have. Pulling, reporting, and analyzing data. Data pulling is the process of collecting data from analytics tools and putting it into a spreadsheet or database, making it easy to access and work with. For example, you might have campaigns with similar goals running on different platforms like Facebook, Bing, and Google. To make it easier to compare and analyze your data, you'll need to bring it all together. One way to do that is by pulling the data from each source, organizing it into a spreadsheet. Data reporting, also called performance reporting, involves organizing and summarizing data to track performance across marketing and sales efforts. This process makes it easier to identify trends and spot unexpected results more quickly. For example, if you've pulled data from multiple sources, reporting makes it easier to tell if one has a higher ROAS than another. Quality reporting provides a clear picture of the raw numbers. It should help you shape questions that can be answered through analysis. Data analysis is the process of examining data in order to draw conclusions, make predictions, and drive informed decision making. If reporting is the what, then analysis is the why. It helps you develop insights that explain the reported results and make suggestions for next steps, like shifting your budget or prioritizing different KPIs. You'll learn lots more about working with data later in the program, but I hope you feel like you've got a better understanding of what data is and why it's so important for marketing and sales success. Now, let's recap. The data produced by performance marketing is an incredibly valuable resource for understanding how well your strategy is meeting its goals. In an entry-level role, you may find yourself pulling, reporting, or analyzing performance data. Through data analytics, you can find out if you're meeting your goals, anticipate customer behavior, and make plans for the future. Coming up, we'll get into some ways to interpret data and present it to others. All right, you've set your strategy, picked your channels, planned your content, and measured your results. Now what? You know that all data should tell you which channels and content are performing well. But what does good performance actually mean? Is it when an ad gets a lot of clicks? When a tweet goes viral? about increased website traffic? With so many different touch points and channels shaping customer brand interactions, how do you know where to start? In this video, we'll explore how businesses use reporting data to find out which of their marketing and sales efforts are the most successful. Success can mean different things depending on your particular marketing and business goals, but every digital marketer wants to know which touch points are getting customers to take action. Say you're running a campaign for a company that sells art supplies. If tons of people are clicking on an ad for a new line of paints, but only a few of them eventually make a purchase, that ad might not be so successful after all. In order to optimize a strategy, you need to know which touch points are influencing customer decisions the most. Of course, you can't know exactly what your customers are thinking. All you have to go on is what they do. But those customer behaviors can tell you a lot about where your efforts are succeeding and where they're falling short. The process of determining which content and channels are responsible for generating leads, conversions, or signups is called attribution. This isn't something you need to determine on your own. Most analytics tools include features that can use your data to find out which touch points and keywords customers interact with. Signups is called attribution. This isn't something you need to determine on your own. Most analytics tools include features that can use your data to find out which touch points and keywords customers interact with before taking action. You'll get some practice with these tools later in the program. Budget and the customer. Someone is shopping for a new computer when it comes to attribution models. We won't go over all of them here, just a few to give you a sense of how they attribute success. Data-driven, first click, last click, and linear. Data-driven attribution measures customer engagement with marketing content across channels to understand what's motivating them to take action. It assigns credit to each touch point based on statistics, like which ads or keywords most often lead to conversions. Data-driven attribution draws on real customer behaviors, all the credit to the first touch point that eventually leads to a conversion. Points for them. Linear attribution assigns equal credit to each touch point along